Good morning. We will start discussing today the forward flight. If you remember, in hover, the wind velocity is constant around the azimuth. If you would name ATP the hover tip speed, you would see that at the at every blade the velocity would be the same, omega r, and the velocity is constant around the azimuth. What is happening in forward flight? Well, in forward flight, the velocity depends on the azimuth of the blade. If you would see that the helicopter is moving forward at a velocity v, at the back of the helicopter, at the rotor tip, the speed would be the hover tip speed. As we are advancing, the advancing blade would see a velocity which is the hover tip speed omega r plus the forward speed. In front of the disc, the velocity of the blade will be again the hover tip speed omega r, and the retreating blade would see the velocity, the hover tip speed minus v, the forward velocity. It follows that there is a difference in velocity between the advancing and the retreating blade. This would mean a different lift, and therefore would means that the helicopter will start rolling. Usually due to the gyroscopic effects, would start going forward. This was the problem of Sierva to develop his autogyro for forward flight. Namely, if you look again at the rotor disc seen from above, in forward flight, the flow around the disc is asymmetric. The advancing blade is having a velocity omega r plus v. Retreating side, it has a velocity omega r minus v. The solution of Sierva was to install the flapping hinges around the blades. The flapping hinge, it allows the blade to move up and down, and if I find the flapping as the blade motion parallel to the mast, you would see that there will be a kind of steady flapping angle that we will learn later is called the coning angle, which is between 3 and 8 degrees. In this way, allowing the blades to move freely up and down and introducing the flapping hinge, we can counteract the inequality of the lift. You see here the rotor hub of an articulated helicopter. There you see a point where the flapping hinge is attached to the rotor. In this way, you can let the blades move up and down. You see also the pitch hinge, which allows the blade to move to change the angle of attack and increase the lift. And you see also the so-called drag hinge, which is caused by the motion of the blades in the in-plane of the rotor, the lead lag hinge or the drag hinge, usually which is also damped by a damper introduced in the hub system. The centrifugal force, it is almost 20 times the blade lift, and in this way, putting the flapping hinge with an offset E, we can eliminate the rolling of the helicopter in forward flight. Therefore, there are certain aerodynamic constraints which limit the forward speed. If, for example, we are forwarding, a helicopter is going forward with a speed which is usually about 120 knots, at the advancing tip blade, we will have the Mach and the drag divergence. we cannot increase the velocity above 0.95 Mach number. At the retreating blade, usually the blade will stall as I told you, the alpha is very big. And then inside the rotor area, we will have always a reversed flow region. In this way, the aerodynamic speed of a helicopter, the forward speed, is limited and cannot be higher than 150 knots. This is the fundamental principle of forward flight of a helicopter.